This clip here, we're just going to have a very quick look at how we would solve a problem. We're given an elevation of a plane, we're given a plan then of two planes. Okay, so in our elevation, we're missing the height for our point F. Okay, so here we have DBE, both in elevation and plan, and I said we're missing the height there for our point F. We have the location of, we have its distance from the vertical plane, so we have its location in our plan. We know it's along that line there somewhere in elevation, but I don't know where yet. But what I am told, and given the dihedral angle between those two planes is 170 degrees. Okay, so in order to solve that, we're going to solve it like we normally would. So we establish the line of intersection first. Okay, so this here is my line of intersection, my line DE. My line DE is the line of intersection, my LOI, my line of intersection. Okay, but obviously I want to see those two planes now as an edge view in order to put on the dihedral angle. So they give me the dihedral angle, okay, as 170 degrees. Okay, so that's what it told me the dihedral angle between those two planes is. Okay, but of course I'm missing the height from a point F, so I cannot finish off the drawing. So the first thing I'm going to do is I'm going to look at those two planes until I have that line of intersection as a true length. So that's the first step. It's not a true length here, and it's not a true length here, as it's not horizontal in either of those drawings, in either of those views. Okay, so I draw an x1, y1 parallel to my line of intersection here in plan, and I'm going to take an auxiliary elevation. Okay, so that's 90 degrees to it. I'm going to set up a 90-degree line to that now for my projection points. Okay, so I'm just using my protractor to make sure I'm bang on with it. Okay, I'm setting up a line now that's going to be 90 degrees to my x1, y1. Okay, so this is my line. So these lines are all projected 90 degrees to my x1, y1. Okay, and of course in an auxiliary elevation, the heights I'm in this view have to be the same as the heights in this view here. Okay, so I'm taking my heights. So I'm taking the height for point E. I'm marking that into my new view. Okay, taking the height for D. Just make sure you're accurate with them. And mark that into your new view. 1 second there now. So that's the height for point D. And mark that into your new view, which is your new elevation. So the heights are obviously the same as this elevation. We're just looking at it from a slightly different direction as we are up here. And the height for point B. Okay, so I label my points in this one again. So that's B, that's E, and point D is down here. Okay, so I can redraw my plane now inside this view. Okay, and the line of intersection has now become a true length. So that DE line is now a true length as we are now looking 90 degrees at it. So our XY is parallel to it here. So we are actually looking 90 degrees to it now. Okay, so what I want to do, I want to just color that in. So that's my yellow plane. So it takes a couple of minutes, add a little bit of color to the plane. It just helps it when you're going through the different views. It doesn't take long. Okay, you'll have loads of time. So just add a small bit of color. And my line of intersection was my line DE. So that's my red line. Okay, so that's there now. That in my auxiliary elevation. Remember, that's my x1, y1. Okay, so that's that marked in. Okay, so now what I want to do, we will look along our true length line. So that's the true length of the LOI, true length of the line of intersection. So we're going to look along it now in order to see our two planes as an edge view. That's what we would normally do. So we're going to do the same here. I'm just going to project the same direction as the true length line is going. So I have more space up here, I think. So I'm just going to project it up this direction here. And the same for point B. Okay, and I need to put an XY 90 degrees to that. Okay, so that there now, that's going to be my X2, Y2. So just go over that. X2, Y2. Okay, my X2, Y2 up, I'm going for my X1, Y1 back for my distances. Okay, or back two views. If I'm working here, okay, I step back two, I'll go, step back, go back two views, 1, 2. So it's my X1, Y1 back to my plan. So again, just get my measurement compass here, and I'm measuring for my point E and my point D. So the distance of those are going to be the same, of course, because the line was parallel to the line of intersection. So D and E, mark them off. So that's D and E. And then for point B, again, set my distance here. And I just have to mark off that distance now in my new view over here. Okay, extend my project line from B to make sure I'm accurate. I don't just guess it. Okay, so that there is my point B. So I can redraw my plane there now, which just appears as an edge. So those 3 points are lined up to appear as an edge. The line of intersection, which is DE, appears as a single point because we're looking right along the line. Okay, so if I have my pencil with my blue tip and I look right along it, okay, all I see is the blue tip of the pencil. So it's the same story here. So we're looking along it. Okay, so we just see it as a point. We are told it's 170 degrees, which is the angle, the dihedral angle that should be between those. And obviously the dihedral angle, okay, that's our line of intersection. So that's where we're going to mark our dihedral angle from. So get our protractor, line it up exactly along my plane. Make sure exact when we're lining it up. Okay, so that's on my 0 degrees line, if you like. And measure all the way around. So that's 90, 100, 110, 120, so all the way around to 170. Okay, so that's at my 170 degrees to it. And I join that back. Okay, so point F now is somewhere along that line. Okay, I'm not sure where yet. I'm going to find out now in a minute. Okay, so remember, when we were going from x2, y2 up, we went from x1, y1 back. So I'm going to do the very same thing here now. I want to find point F somewhere along this line. Okay, so I'm going to take that distance from x1, y1 back to F. I'm going to mark it above my x2, y2 and go along until I cut my line. Okay, so get my compass. I'm going to measure the distance from my x1, y1 back to point F. Mark that into my new view. Along there. So parallel to my x2, y2. And put in that height line until I cut. And that's my point F right there. Okay, so I have it found. What's some of the rest? I don't need to fall that far back. Okay, so point F is right there. Okay, so again, I took my distance from x1, y1 back, marked from my x2, y2 up, and went across until I cut, because I knew that was my plane, so that has to be location for my point F. I'm just going to extend my x2, y2 now in order to cover that. Okay, so that's my x2, y2, that's my point F. Okay, so that's my blue plane, and I'm just going to project point F back now into my other views. Okay, so that's it there. These were all projected looking along the true length. Okay, so we project them back down again looking along the true length. So I'm going to do the same for F until I cut the projection line coming from F. Okay, so I'm going to project it back down the very same direction. Okay, that gives me a point F in that view now. So I can line that in. Okay, so that's my point F now inside this auxiliary elevation. Okay, so if it's in this auxiliary elevation here, it's after giving me the height that I need to mark it into my normal elevation. Okay, so remember when I went from my x1, y1 up, okay, I was going from my original xy back to my elevation. Okay, so the heights here have to be the same as the heights here. So if that's the height of F here, it has to be the same height up in this view. Okay, so I set my compass, get the distance of it in that view, and mark it there into my elevation. That there now is my point F. And the same thing again, I just add a bit of colour to it. Okay, and finish off the view. So that gives me the projections of the point. So even though I didn't have it given to me originally, when I was given the dihedral angle, I can work back then and find it.